myself up. Hey, guys and gals and everybody else, stargazers, this is Ronnie Heron on the screen with my buddies here on behalf of our longtime astronomy and telescope club, the Santa Barbara Astronomical Unit. Welcoming you to the SBAU Astro Hour, our weekly vlog podcast emanating from our homes and featuring, I'm here to say, some of the brightest, most knowledgeable minds in Santa Barbara, California. I call these guys our brain trust. Yet there's still a lot to learn, and we do every week. For going on 5 years now, we cover all space stuff, cutting edge cosmology with news, new discoveries, research every month. Look us up online, sbau.org. And we're headquartered up at the beautiful Santa Barbara Museum of Natural History. Here's this week's topics, okay? Number 244 already, my God. It's the planetary watch. Where the heck are they now? All starts with Mercury, goes outward. Way out in the gas giants, we found something orbiting between Saturn and Uranus, now known as Doug. It's not as big as a planet, but it's big. It's got its own rings for getting them. What and where is the rising princess? Well, it's high in the sky right after sunset. First quarter moon comes Wednesday morning, mid-morning, and it's in Capricornus. It's the Terminator we'll focus on this hour. Got a spooky open star cluster out there called NGC 7789, the Screaming Skull. Happy Halloween. And a tale of three comets. One's a swan, another's a real lemon, and then there's our Royal Interstellar Visitor Atlas. All three of them come with tales. Let's meet our guys here in charge of the Starship Astro Hour crew. Commander, man behind the talking points, beloved president of the club, Jerry Wilson, wants to say
good morning, everybody, and good morning, Joyce, Riley, and Calvin.
That's right. Joyce, Riley, and Calvin take the day off. You have our permission. He's also, he's also married to Pat, one of two Pats. The other, Pat Forgy, is his wife. The other's married to our outstanding captain outreach, Chuck McPartland, in front of the Ukrainian flag, co-pilot of this aircraft or spacecraft. His wife, Pat, is both our club's merchandise manager and treasurer. Science officer for the club is Tom Whittemore, former science instructor. There he is.
Science officer.
Well, I'm just...
You got a promotion.
How did I get that?
We go where no other group of old men have gone before.
Okay.
Except maybe Neil deGrasse Tyson with his Star Talk. Anyway, Tom is married to Maureen. How's she doing?
Oh, fine.
Are you out bird watching? You're a bird watcher, aren't you?
Yes.
Okay.
Yeah.
And then you got plenty of sesame seeds from your bread baking to throw out the window and get them to come to your backyard.
You know what I end up doing is buying something called Scratch that you just feed the chickens, and the birds here love it. They just love it. It's
cheap. Is it made of corn?
Corn and peas and all kinds of stuff that chickens like to eat.
Huh. You know, my daughter gave me the remains of a 20-pound bag of bird seed that I like to feed the birds on my porch. They won't eat it. You know what they love? They love the end crumbs of my chips. Chips and corn chips.
So by a strange coincidence, my cat loves chicken. So
all works something out. Hey, our navigator on board the Starship, Tim Crawford, as a
resident. Oh, man.
Yeah, long-time member. His wife is Karen. And doggone, if the onboard Vulcan first mate is Bruce Murdoch. Check out his pointed ears. Also president of the Santa Barbara Theater Organ Society, and his lovely wife is Bonnie. I hope her health is doing well, maybe in remission. She okay? You're taking her to things? Or...
She's, you know, the cancer she has can't be cured, but it can be treated. And so far, the treatments are working.
Excellent.
Yeah. So far, both those treatments are just awful. Radiation and chemo. Hey, we got silly stuff though to get out of this drudgerous bag of feeling bad on things. We're getting old and we're all happy and mostly healthy. And Jerry sends us these cartoons during the week or thought provokers. When you get bored in physics class, take a good look at how that guy scribbled, scroll, doodled his textbook off to the left of the picture of Albert Einstein. I don't know.
There's no respect.
I know it doesn't do a thing for me, even if it was Raquel Welch at my age. Now, this one's going to need to be fleshed out, or, well, maybe not. Please do not move coffee machines. It will change settings. We don't see them. So you want to re-highlight that, Mr. Prez?
Yeah, hang on.
Mr. Starship Commander? Because it was a pretty interesting thought, and I wrote something down about it. What did I write? Quantum entanglement. We're going to do an entanglement here, ladies and gentlemen. Stand by. Have they invented a quantum computer yet? They're still working on it out at the university, aren't they?
There are several models, yeah.
Yeah.
They have several, yeah.
They take a lot of power, and just like the old UNIVAC, take up a lot of room, don't they?
They consume a lot of power. Mostly the power is not for the actual computer. It's for the refrigerator that keeps it at a fraction of a Kelvin.
Oh, keeping it cold.
Yeah, when you see that big thing that they always advertise as the quantum computer, it's this array of gold layers and gold wires and everything, and it looks really impressive. That's not the computer. That's the chiller to get it cold. The computer is actually this little thing smaller than a dime at the bottom.
Yeah.
Well, New York Times is talking about an AI bubble about to burst like the housing did in 2008 and the internet did in the 90s. I still don't see the coffee machines. Do you guys? Were there pictures?
There was no picture with that, Ron. It was just text like this.
I'm sorry, I thought there were. Please do not move the coffee machine. Doggone, it'll change settings. That's from the engineers. Physicists say, please do not observe the coffee machines. It'll change quantum states. We'll be able to see the grounds, or they'll move. Or this one I like. Comparing Einstein to Darwin. Everything is relative. That's right. But according to Charles, everyone is relative. We're only 2 genes away, or just the 2 somethings away from a chimpanzee. Here's the Carp Diem cartoon. This is an all-new business that you won't see too often, but who knows? The Small Black Hole Creation Center is on vacation. Haven't been, sucked in with all the information gone. That's funny. Okay, here's the astronaut walking his Astro dog for its potty run. He says, would you stop sniffing everywhere and just go? It has to be in its suit. Interesting stuff. I guess this is if dinosaurs had continued to live and we hadn't come along, they'd have their own trick or treat. And
this is Halloween and the dinosaur times.
Oh, back then, okay.
He's wearing a scary costume.
Oh, I see that. I got it. That's the one. It's after the fact.
But just what are they handing out to put in that bag?
Oh,
the
yeah,
bowl looks
right.
empty.
Little mammals. The Off the Mark cartoon. This is a skeleton as you'll never see it coming toward you. Gives you a kiss, and it gives you a hug. That's like those little X and O's they put at the end of letters. Exoskeleton.
Be good.
What insects have it? An exoskeleton.
Well, X means kisses and hugs.
I understand that, yeah, but I'm
Okay.
sure that's the play on the words.
I guess you had to be there.
Yeah, that's true. I mean,
No,
crab,
that's a great cartoon.
like it. Okay, now that put us in a good mood. The sun just came out where I sit. I'm waiting for my nurse to show. And we got stuff to talk about, gentlemen, starting with the planets. We have a night sky here. There it is. There you go. Pretty much how my horizon looks after several drinks of scotch.
So this is working our way down the planetary roundup for this week. This is actually tomorrow evening, and this is Mercury and Mars just about to set. Now, the sky will not be this dark at this time.
The sky won't be dark at all, since that's not till after 6.
So anyway, but they're there. They're tough objects to find.
Yeah.
All of them. We can see all 9 or all 8.
Yeah, Jerry, we got Mercury in binoculars last week, but you notice how Mars and Mercury are lying on the ecliptic?
Yeah.
Almost look like they're lying on the horizon,
Yeah.
So the ecliptic is just very shallow. So these are really tough. They're really
Yeah.
tough to get. Okay.
But you're up on a hill.
Right. And
You're the only
actually,
one of us that stands a chance.
speaking of that, Friday night when we came back after concert, a music concert, the fog was basically making the Milky Way just absolutely spectacular up here. It was,
Oh, yeah.
Oh,
it
because
was
of the fog
really
down
nice.
below. Yeah.
Yeah, all the fog was down below, and I just looked up in the sky and you could see the Great Rift and Cygnus. You could see all that neat stuff.
Hmm.
It was really beautiful.
Charles Schuler and I were up on East Camino Cielo,
You got
and
to
we're
look
looking
then.
down on that. It was just spectacular.
Wasn't that neat, Bruce? Yeah.
We had great nights both nights for the camp out too.
Okay. Okay.
But you can see Mercury after the sun sets. It's part of the dark sky.
Well, it's about a week ago. Yeah, it was pretty easy to get. We did use binoculars because it was a little hazy out there, towards the southwest.
To me, it would just seem like it's got to always be there and near the sun, and it'd be very hard to see it. But maybe it's out far enough, what, 30 million miles or so?
Well, it never gets more than what, 19 degrees from the sun?
It could get in the low 20s, I think, Chuck.
Okay.
Uh-huh.
So the rumor is that Copernicus never saw it.
Yeah, yeah.
Huh.
And in this case, of course, like I said, if the ecliptic is shallow like that and slanted, even though Mercury might be getting 20 degrees or so away from the sun, it's really tough to pick off because it's still close to the horizon, you know.
Well, we got 6 to go then, don't we?
Mm-hmm.
Now, and of course, this is the early morning. You can see the planetarium software puts a ray of the rising sun about to rise, so it's about here.
Mm-hmm.
So Venus is nicely placed
Yes.
in Virgo.
And Arcturus is should be a wonderful morning object, but we just been getting a lot of haze, so can't see it. Yeah, yeah. It's again the time of the year when Arcturus you can say good night to and good morning to.
Yes. Oh,
All right.
this is Jupiter, and I think
Mhm.
in there.
Yeah, falling towards Cancer.
Yeah, Jupiter, but there was
Oh, Eskimo, that's a Tim favorite.
yeah.
What's that?
Yeah, this is just the Jupiter finder.
Mm-hmm.
So that's up in the Gemini, the twins.
Yeah.
And this is about 2 in the morning. So
Yeah. And it's overhead and it's really nice and bright.
Mm-hmm. And during the summer, Jupiter was kind of in the middle of the twins, but you can see how it's been falling slowly towards Cancer.
I'm sorry, did I miss Mars?
Mars was on there with Mercury.
Yeah,
Oh,
that's
okay,
West-
gotcha.
Western sky, Ron.
Gotcha.
See,
Sorry.
here's Mercury and there's Mars.
Ah,
Both, I think, basically impossible.
They're pretty tough, Chuck. Yeah.
Now, this, according to Astronomy Magazine, is Jupiter as it would appear in a 6-inch telescope with
And-
a tower.
And really washed out.
That's about right.
With chromatic aberration too.
no
Yeah.
layers, no red spot, huh? Okay.
Okay, just a second.
Can't wait till we get to that little body between Saturn and Uranus.
Well, that's been known for a while. Chiron and
Oh, of course.
Cardiolo and those things.
Yeah, we all knew that.
They just didn't know there were rings.
Okay,
There we go.
so this is about what you'd see in a very small scope, 6-inch or something. You'd see the 2 bands across Jupiter, making it look like a cheeseburger. But if you have a really good scope and very steady skies, you can see a lot more than this.
Mhm.
And I'm thinking of my 5-inch refractor.
Wow.
Now, this is Neptune and Saturn here
Mhm.
in, what are they in? Pisces. Oh, one's in Saturn, one's in Pisces, one's in Aquarius. And these
Just over
are,
the boundary.
yeah, these are late evening objects, about 10 o'clock. Wish that flag had stopped showing up. And these red things are asteroids, usually among the top 5, but I don't take time to label all of them.
They move a little different than the stars, don't they?
They move differently than the stars. Yeah, they're just basically another planet for a wanderer.
Mhm.
And at one time in the past, I understand they were all considered to be other planets. Since they couldn't really resolve planets anyway, they were just looking with their naked eye.
Well, a couple of them are dwarf planets.
They didn't find asteroids until the telescope age, but
Is that right?
yeah, but they counted them as planets until photography came along.
Yeah.
Hmm.
Yeah, ditto. This is what Saturn would look like in a very small telescope with the power run way up. And again, my telescopes under very steady skies give a much better image in this.
Yeah.
You can see a lot of the separation in the rings, maybe not at this attitude, but normally when the rings are open, you can see a lot more detail in them.
Yeah, wait a couple of years.
Yeah.
From East Camino Cielo, Saturn was spectacular.
Yeah.
Mhm.
It's
This is Saturn we're looking at?
Yeah.
Yeah.
Doesn't seem like the rings are out far enough.
Well, it hasn't gone around in its orbit such that it tilts them toward us. Wait, you have to wait a couple of years?
Yeah.
Okay. Galileo's ears.
Yep. Big ears,
Yeah,
big handles.
handles on.
Finally, here's Doug,
Yeah.
partway between the Pleiades and the Hyades.
Hmm.
So this is in the late evening, 10 o'clock at night.
Mhm.
So this
Okay.
stuff was more early morning stuff, early evening stuff.
Yes.
So it's getting ready for the winter constellations to take over the evening sky. And the winter constellations have most of the really bright stars, so it's quite spectacular.
Hmm. This weekend, right? We go to wintertime time.
What's that?
This weekend, did we go back? We set the phone, the clocks back.
Yeah.
Next, right, 7 days from yesterday.
Pick up a little light in the morning, but go real dark early at night.
Yeah,
And
it's gonna be dark 30 pretty soon.
The cartoon that I tried to send, but it didn't take, showed a clock face, an analog clock face, and someone had taken a black marker, and they'd crossed out all the numbers on the clock face and rewritten them all an hour advanced.
Oh, there's no reason to post it next week
There
now.
you go.
I don't know why it didn't go through. All the rest of your cartoons come to us.
Sometimes when I send it from my cell phone,
Oh,
it won't grab the photograph if it's inside the message. It has to be an attachment. So this is an artist rendition of a asteroid or a Kepler.
dwarf planet.
No,
Not a dwarf planet?
no.
Well, it
It's a
looks
centaur.
round. It looks
It's a
totally
centaur.
Okay.
This is the world Chiron, which orbits between Saturn and Uranus, and may be building its own ring system. So
And his ring systems were on both Chiron and Chariklo were found with occultations.
okay. So Chiron, Chariklo, as you mentioned, Haumea, and Quar also have host rings. This one appears to be establishing its rings, that is, it's growing it.
Did you write that this sucker is about a couple 100 miles across?
In that neighborhood, like
Yeah, I
100.
think that's about right.
Okay, wouldn't that be up there with the Ceres and
No, the series is 600 miles across.
okay, so that's about as
120.
small as you can be as a dwarf planet.
They haven't really come up with a good definition of dwarf planet yet, so you're going to see all kinds of arguments about that.
Isn't Pluto?
Maybe they'll promote Pluto back to a planet then, huh?
Yeah.
Isn't Pluto?
The body of Chiron is 125 miles wide.
Oh wow! Wonder what Chiron came from. Sounds ancient.
Chiron is a centaur.
Oh, What's the moon around Pluto? It's got a similar name. Charon?
Charon.
Okay.
There were various centaurs in Greek mythology that had names, and this is just one of them. And
Centaurs
because they
are-
call these objects centaurs, they give them names of centaurs.
What's a centaur? Half bull, half man?
Half horse, half man.
Half horse? Are you? Oh, no, that's Pegasus, isn't it?
No,
No,
Pegasus is a flying horse.
Flying horse.
Oh, got it.
So the
Half
centaur
of it cracked off.
is half human, half politician.
Yeah.
But isn't Pluto smaller than our moon?
Yes,
And yet our moon is not a dwarf planet.
because it's orbiting us.
Yes, yeah.
So it's who it orbits. It makes it
It's
either a
part of
moon
it,
or-
yes.
But
They,
is this,
they picked a really lame definition of planets and dwarf planets. They should just call everything planets
but is this thing we're
and
looking
just
at
say
right now,
it's fuzzy. There are categories.
is this Chiron or Charon? Is it part of a light little extra band of asteroids between Saturn and
It's not a band. There's not enough to form something that would look like a band, and they have different inclinations. But there's a population of asteroids there.
Huh. Huh.
There's also a population of asteroids interior to Venus.
Yeah.
Really?
Interior to Venus's orbit.
That's
Between
right. I think
Venus
you mentioned
and,
that
and
last
Mars
week.
and
Mercury.
Bruce? What were you saying?
Mercury. Yeah. So there's this other layer of asteroids is between Venus and Mercury, correct?
It's not a layer, but it's a population of asteroids.
Yeah.
Okay.
They're really everywhere. No
Yep.
wonder they're giving us problems. Scaring
They're
us.
pretty soon. They're going to be moons of Saturn soon.
Yeah.
That would take a big upset. It might have been moons of Saturn once.
Yeah, yeah.
Here's the
You notice that
Terminator.
that population keeps going up, Jerry. Doesn't it's too bad it doesn't go down.
Is
It's getting hard to keep up with.
Did Saturn pass 200?
274.
Okay.
What was it again?
274.
Oh my God.
Okay, this is one of our moons. We have one moon and then occasionally a temporary moon. But this is our more permanent moon. And on October 29 at 9:21 a.m., it's exactly first quarter. This is referred to as the Terminator.
I'll be back.
I'd be back.
Yeah.
So it's got the best viewing along this line because the shadows are very good. Now, in the talking points between the Chiron showing its ring, I had a paragraph in there called the princess. No, I did. Yeah, the rising princess. That was something I intended to edit out, but I guess I didn't. But I didn't populate it with pictures, so we're not going to cover that topic this week. But it's looking at all of the, it's from Astronomy Magazine, and it's looking at all the galaxies in the Andromeda region, but not the big galaxy itself. So we'll look at that another time.
Oh.
People at home don't get the talking points, so they don't know what I'm talking about.
Well, some of those galaxies they call a local group, don't they? Is
Yes.
The ones that are close.
that the ones that orbit the Milky Way and not Andromeda? Or are we
No.
all part of the same group?
Andromeda is part of the local group.
Okay, so we're all together, coming together, defying dark energy.
There are galaxies around M31 that are orbiting M31, and there are some in the background that are way out of our local group. But we'll see that. This
Okay.
one is taking advantage of the high contrast of the moon at this phase. And we're looking at a couple of craters down here in this region. And they are Stevenus and Phanarius.
Stevenus and Phanarius.
Now, this is sort of upside down from the picture of the phase. This is, but this is Phanarius down here. This is Stevenus, and this is the very easy one to pick out, Petavius. due to this fault going from the central mountain peak to the ridge.
I've never looked at that.
It's the only crater that I know of on the moon that has this prominent feature.
It's available.
So what we're looking at, let's go to this. This is
Wow.
go ahead.
It's like that follow-up spike in a water drop that goes away and gets flat again. But in this case, it would be hot lava doing its follow-up spike, and then it's froze in place.
That's where a lot of these central peaks are believed to have originated.
They freeze over that fast.
Thank you.
They do pretty fast. You're radiating a lot of heat, and they generate a lot of heat. When two solid bodies like this hit, and they're doing tens of thousands of miles an hour when it hits. That's a lot of kinetic energy, and it goes immediately into heat. So these objects, when they hit, they can be viewed as two liquid drops hitting each other.
Huh.
Do they have a scientific name for that follow-up
A
spike?
central peak.
Central peak is, well, that's what they'd call it on a crater, but what do they call it in water?
I don't know the name for that.
I think a rebound drop or
splash.
something like that.
Rebound.
Bloop.
Yeah.
But this is a beautiful crater straight on. This is from, I think it's from the Lunar Orbiter.
Wow.
Yes, the Lunar Reconnaissance Orbiter. So it went over and it looked straight down on it.
Wow.
Now this is the region where it is.
Mm-hmm.
Whoa.
And let's see.
And this is a pretty low contrast view compared to the nice shadow view earlier.
Yeah, I tried to boost it. So this is Petavius. And this crater is one of those, and another one, these two are called the headlights because of their ray pattern. And this is a picture during the full moon of the headlights,
I'll be darned.
close
I'll
up.
be darned.
Wow. Headlights.
Someone spent a lot of time looking at the moon visually.
You know, the thing I like about our science is the simple names we give things: black holes, sunspots, light year, and what was that called again?
Headlights.
Headlight.
Now, this is two pictures taken by my Facebook friend in France, Robert Cazellac. And the one on the left, he took with a C14 Edge HD telescope. And he claims the seeing is roughly 7 out of 10. And on the right is a lunar reconnaissance orbiter picture from a quick map by NASA. And his process picture, actually, in my view, shows comparable detail, if not in some cases better.
Well, it's a little higher contrast than the one that NASA had there.
Yeah, this one up here, we see a little more detail around it, and here it's a little blurrier. So,
A little darker on the right.
yeah, he does good work. If any of you speak French, I don't take the caption off.
Right. Oh, you can see the chapeau. It
Yeah.
does look like a hat. You see
Yeah.
that? Looks like a little hat.
Like those French revolutionary
Oh,
hats,
yes, it
right?
does. I just got that.
Yeah,
Thank you.
chapeau de pompier.
Yeah.
The jellyfish without the arms.
Yeah.
You're talking about the fan shape around it?
Yeah.
Lighter
Yeah,
gray?
it looks like Napoleon's hat.
Okay, well, would that mean the meteor came in from the bottom?
This
This
is a
is-
different kind of feature.
Yeah,
Oh,
this
it's
is
not-
not an impact crater.
That's not spray. Okay.
There might be a very old impact crater under there, but this is after the sea formed, after there was a general outpour of lava, because there's a lot of space without craters. And when you do get craters, they're smaller craters, so probably more recent. The solar system is running out of large collision objects.
Well, that's too
Luckily.
bad. Sorry to hear that. But these are the headlights?
No,
Oh, no.
we changed topics.
Oh, we went past the headlight. I'm sorry.
This is the headlights
Oh, got it.
under full moon to emphasize the ray system.
On high beam, no less.
Yeah.
Why would they reflect so much wider? Is it something that they're into the soil?
Yeah, the minerals there, the anorthosite has tetrahedral crystals that are really good at reflecting light directly back. But as they're exposed to the solar radiation, they darken. And so this is showing you these are young craters.
Yeah, yeah. So it would be age, okay.
Yeah.
The average reflectance of the moon is only 16%. So if you get something that hits it and it exposes the white layer underneath, it really stands out.
Why is everything gray up there?
Because
The
it,
radiation from the sun.
yeah.
In
Yeah,
other words,
the sun,
all
basically
those
the
different
solar-
colored
solar-
elements, like gold.
Solar wind is protons.
And it
Yeah,
turns
Ron, basically the moon has the reflective property of asphalt. You know, that's why I've
Yeah,
often
right. Like a street.
yeah.
well, if we painted everything white, including the streets, we'd probably have more reflected sunlight into space and less global warming, wouldn't we?
It would help.
Yeah.
With the ice melting, we're getting darker, it's getting warmer.
Yeah,
Part of it.
amazing.
We at Santa Barbara Research Center, when we put a weather satellite up, we turn it and point it at the full moon, and that calibrates our exposure time. Because we know as was pointed out, we know the albedo of the moon very accurately. The average reflectance.
What's the magnitude with a minus sign on the moon? Do you know?
Full moon is like -11.
Good Lord.
13? Mine's 13, full
Okay.
moon.
Yeah, it's like half the sun.
Yeah.
But half doesn't mean half.
Yeah.
No, half doesn't mean half, but half the number.
Half the
Yeah,
number?
it's like, yeah.
But imagine what our viewing would be like if it were white instead of gray. Wouldn't be able to see anything in the
Minus
sky.
13 is 158,000 above the white, above zero.
Every now and then you see someone that has processed. There's very subtle colors in the moon.
Yeah.
Due to its mineralogy. And every now and then you see someone that has taken that and exaggerated, oversaturated from what your eye would see. And it shows a really colorful moon.
Yeah.
You get bluish from the titanium, you get orange colors. Yeah, there's other colors there.
Yeah. You just don't notice it. And if you look at the moon, full moon in something that's very fast telescope, like an F4, the full moon unfiltered, it will actually hurt your eye to look at it.
But they call Mars the red planet because of what iron, and yet there's not that much iron on the moon to
Yep.
give us any red out there.
It's not just iron, it's oxidized iron.
Right, iron oxide.
Oh, because but oxidation requires oxygen, doesn't it?
Yeah.
Right. And there's plenty of that on Mars from the water that got dissociated.
It's
But
called rust.
there was never oxygen on the moon.
Ron,
Rust.
it's called rust.
Yeah, that's amazing.
Okay, what we're looking at here is Caroline's Rose Cluster, or Stephen James O'Meara's Screaming Skull.
I just can't see that.
I don't either, but anyway, this is where it's located.
Okay.
It's up here near Calf, in Cassiopeia,
Mhm.
up here. And this is a very nice object to photograph, the Bubble Nebula and M52.
Mhm. A nice open cluster.
Yeah, and here we are over here with Andromeda, the M31.
Now that's where the red circle is. Is that Caroline's Rose?
Yeah, that's where I put it, yeah.
Oh, okay.
The planetarium software here, the Sky 6, shows the object when you're highly magnified, but as you zoom out, it drops the label. So I just put the cursor on it. Most of these programs have some shortcoming. They're excellent programs, don't get me wrong, but they have some shortcoming that you have to learn to overcome.
Yeah.
Yeah, you need to really fiddle with the settings to get just what you want sometimes.
Yes, yes.
So Carolyn's Rose is known as the Screaming Skull? That's what I didn't get.
I
Oh,
don't
it's
know if
Carolyn's
that's
Rose, but it's occasionally called the Screaming Skull.
Screaming Skull. Wow, that's weird. I never know that.
that's due to one guy,
Yeah.
a guy that writes articles for Sky and Telescope,
O'Mara?
Stephen
Yeah.
James O'Meara,
Okay, okay.
and this is the Screaming Skull.
Yeah.
Certainly scares the hell out of me.
I think he might have just come from a party or something.
Yeah.
Does it also have a big nose?
I don't know. I don't know. You'd have to have him explain it. But this kind of looks like a cavity. This is the cluster. This is kind of a, I think, probably a lot of dust on that covering that part. So
Yeah, you can sort of squeeze a little bit of a skull out of that, but Carolyn's Rose sounds a lot better.
Yeah. Is that the same as the broken heart, Chuck? Because
I've never heard of the Broken Heart, so I don't know.
I've shown the broken heart at Westmont, the refractor.
Uh,
I
you've
thought,
done Carolyn's Rose, definitely.
oh, absolutely. It scintillates. It's so pretty. Yeah.
See if
I can see
find
Mickey
one.
Mouse there also. No, the two what are
Ears
they?
up top,
yeah,
yeah.
now Mickey Mouse I can get. That pops out as soon as you said it.
Or like a dog looking at you, or a bear, or a big-eared bear.
Yeah.
Hmm.
Okay.
Pareidolia.
Amazing,
Yeah, that's it. Yeah.
amazing how many of our holidays get mentioned in the sky. There's a Christmas tree nebula, and there's a screaming skull here, and those hearts and roses sound Valentine's Day
No.
to me.
Tommy, the Broken Heart cluster is in Ariga, and it's 2281.
Okay. I've shown that one. I know that.
Yeah.
It's really beautiful. And you
No,
can see it's split. It's split.
Okay, if you squint your eyes and look at it, you can see two eye sockets, the one there and one there, and then an open mouth. So that must be where he means by the screaming skull. But you have to squint your eyes to see it.
And the way I've managed to see something like that was more like he's facing down toward the lower right corner.
Yeah, I tried that too.
Yeah, and the jaw is hanging down to the left there. Yeah, a little. Yeah. Anyway, yeah.
Well, I saw the big nose above that dark area that looks like his mouth.
Uh-huh.
It's toward the rock.
Yeah. Yeah. Uh-huh.
Wants to give you a hug and a kiss.
Anyway, the reason that's put up here is because we're approaching All Hallows Eve.
Mhm.
That's right.
There's an observing list of Halloween objects, where there's the witch's head and the witch's broom and the screaming skull and the ghost of this and the ghost of that.
Yeah. Yeah, last week we did the Ghost of Saturn.
Yeah.
Why we
Okay,
love
moving
astronomy. So simple.
Aha, lemon.
Comets are us.
We were getting views like this from the campout.
Oh, really?
Yeah. David had that in his Sea Star.
Yeah.
Yeah.
Right. He
Also
mentioned it yesterday when we were showing the public the sun, that he got a really nice view of that comet.
Okay, which one of the three is this?
Lemon.
Lemon.
Oh, the lemon.
This is taken by a Celestron Origin 6-inch astrograph.
Oh.
Stack of 50 10-second exposures.
Hmm.
The stars are from only one exposure, so they're not stacked.
It's got an awesome tail.
So he guided on the centroid of the bright spot down here.
The tail is really nice and long, yeah.
And it's got some structure in it too. It's very
There's
good.
two of them. At least two of them.
Yeah.
You could see this with your naked eye up at the lake?
No, this is a view through binoculars and through the sea stars.
Oh, okay.
Some comets in the last decade we could see with our naked eye, right? Just before sunset, very dramatically. This is not going to be one of them.
Well, since I learned that some comets have two tails, have you ever seen one in your telescope that both
Many times.
many times? Two.
Well, you can see two tails here. There's a wide diffuse one, and then the ion tail is the narrow thing down the middle.
Oh, they sometimes overlap.
From our point of view, yeah.
Can they ever be totally many angles away from each other?
Well, they're caused by two different phenomena. The ion tail is the solar wind pushing it away from the sun, so it's opposite. It's streaming away from the sun. The dust tail is in the orbit of the comet.
If you look at some of the Hale-Bopp pictures, you can see quite a dramatic difference between the ion tail and the dust tail.
Well, I remember in middle school being told by the science teacher the tail of the comet always faces out away from the sun and nobody knows why. And I used to think, well, of course that there's a reason for that. It's the solar wind.
Solar wind and
Solar
even just
wind.
light
Didn't know
pressure.
why.
Say again?
Your teacher didn't know why.
Yeah. Yeah, not only the solar wind, but just light pressure will do that for like the dust particles.
Yes, certainly.
Okay.
This is Comet Swan, and it was taken a while ago on September 15. And this is passing the bright star,
Pica.
Pica.
We were seeing Swan also from the camp out, but it wasn't much of an
Is this a
evident
composite
tail, just
photograph?
a little bit.
It doesn't say how this was processed, but I would guess that the comet is stacked and the sky background is either from a separate set of images without a comet in it. We call that now the
Watson process.
the Watson process. And from Tuesday's telescope Tuesday, or the telescope workshop on Tuesdays. And the stars are not streaked. The comet is not blurred. So this has to be a composite. You can't get that with one snapshot.
Yeah, Chuck Watson, who's in our group, he came up with the idea that you can't, you can get the stars, you see the trailing stars or the comet. So he said, just take the photograph a day later.
Yeah.
So it's the Watson process.
Do you suppose,
Well, there's
gentlemen,
software that'll separate the comet from the stars, the background stars. So you can separate and process those two images separately and then put them back together, and they're both not smeared.
this is more
In the composite.
Is this comet we're looking at here, Mr.
This
President?
is
Atlas.
Yeah, this is Comet 3I Atlas.
Our unwelcome visitor.
Now, I saw a quote somewhere on the web that says Avi Loeb is now saying, the comet is hiding behind the sun and orbiting, changing its orbit out of our view so that it can sneak up on us. And it's like, I can see internet crazy saying that. And even though Avi Loeb keeps saying, oh, it could be a foreign spacecraft, I can't see him coming up with BS like that.
Oh,
Now, I had a question for you, Jerry. This and you guys is that this is 3I, but I saw a program today on that how the universe works and all that. But then they were talking about 67P. Is it also an interstellar comet?
No. P
Oh,
means
okay.
it's periodic, so it's
3I
captured by
is.
the sun.
Okay.
The other ones were Oumuamua and
Borisov.
Borisov. Thank you.
Okay.
Yeah, 67P is Churyumov-Gerasimenko, and that's the rubber ducky one that the European Space Agency visited.
Right. They were talking, boy, they were really going into that. It was neat that how the outer layer of that comet was really soft. They didn't expect that.
No, it was hard. That's why the lander bounced.
But part of it, and the outer shell was like a cigar ash. That's what they said.
Well, the area between the two lobes was definitely more like cigar ash, but yeah, there was definitely a very hard layer they didn't expect.
Okay.
Now this is a picture of the actually these both taken with the Gemini North telescope in Hawaii. It's a 2-meter twin telescope image of a jet erupting from the comet in the direction of the sun. That's the inset. So this is the jet. I don't know what this is. I think this is away from the sun. So this
An arrow.
what's that?
It's an arrow.
Yeah, it's a pair of arrows. I think one of them is the
Right.
anti-solar direction, or might even be solar direction, and the other one is the motion of the comet direction. So it looks like it's going
Ion?
almost directly toward the sun. And so I think the jet would be more the thing on the left and around, you know, just
I don't
getting
see-
curled around.
So, but what
Well,
would
what
make
about that little
what would
narrow
make it
or
curl
short
around?
red line that's coming out at about 2 o'clock?
Yeah, that may be, well, doesn't look parallel to the velocity vector. I don't know if the arrow up above. They definitely need a little you know, caption here telling you what the symbols are.
Yeah, yeah.
Yeah,
But you
it's
can see
pretty
the
parallel
motion.
to the 2 arrows that are up above.
You can actually see the motion from that star underneath it that's got multiple images. So it's definitely moving in that plane, the comet.
Yeah, and this is a negative image.
Yeah.
But
So-
it's not behind the sun.
No.
It is now, from our
Yeah,
point of
well-
view on Earth. And people were saying, oh, it's deliberately hiding from our view. But there are several satellites that can still get images of it, especially solar observing satellites.
Huh. And it's not long tube shaped like Oumuamua, is it?
I don't think we know enough about the shape because it's so active that we can't see the actual image, the hard, solid body.
Yeah, I haven't seen a definitive number for its diameter.
So it
Oh,
came
it
out
looks
of,
like that, whatever it was that went by, the whole bunch of dots was tumbling.
Well, that's probably seeing variations.
That's, yeah, I think that's seeing now this scale along here. This is from here to here is 5 seconds of an arc. From
Oh,
when I take pictures of the sky, I'm very lucky if I can get a star image that's about 3 arc seconds, about this distance or smaller in diameter. So the fact that this could be atmospheric turbulence is completely credible. The 3 is well short of my theoretical limit of my 18-inch telescope, but it's about the atmosphere. It's limited by the atmospheric turbulence. Of course, I'm at sea level and Hawaii is not.
Yeah.
So anyway, more to come. As you know, this comet is going past a lot of probes that are on their way to Jupiter, at Saturn. And so there's a lot of information taken from those satellites. It's being processed and slowly talked about. So we'll have more in the future.
so the Juno around Jupiter and the Parker around the sun might get us pictures.
Juno, probably not. Or
The comet is not coming within 1 AU of the sun.
yeah.
And it's not coming close to our Earth.
No. It's
Okay.
it's already passed by Mars.
Yeah.
I think Mars has taken some images of it.
Yeah.
Will it leave behind a radiant just like all our regular comets?
Leave behind a what?
A radiant of stuff left. That,
Oh, a meteor shower?
Yeah.
No, it doesn't cross our orbit.
Yeah.
Oh, it doesn't.
So we'll never run into its trail.
But I wonder if science has ever attempted to retrace all the comet orbit trails. It would probably make our solar system look like a ball of yarn, wouldn't it? Or even worse than
Yeah, it's been done.
Has it been done?
Yeah.
Because we pass through a radiant for meteor showers every week or so, don't we?
I wouldn't put it that often. But there are quite a few of them. And every now and then I read about where someone has just been figured out that this meteor shower comes from that comet.
From what comet? This one?
No,
from-
just
They
a
identify where those meteors came from, which comet.
Oh, gotcha, right. Amazing.
Okay, now,
Yeah, Orion is behind us, isn't it?
Well, it's still, you know, it was very inactive, it seemed to me. I was looking every day at spaceweather.com at the number of fireball images there were, fireball detections. And it was
Okay.
very low through the entire Orionid period, which goes 2 weeks on either side. So we're still in it.
The days of getting a light show at night are pretty much over, aren't they? Don't know why. Remember in the
Well-
past, when they'd have the whole sky was lit
Yeah,
up.
well, that's where you pass through clumps of debris that have been released by the comet in various passes. And those get perturbed by Jupiter and by, other planets and stuff. So we gradually lose them.
Yeah,
Do I have 3 sheep on my screen?
yeah.
Yep.
Okay, why are there sheep there, Mr. President?
We, at the last time, we showed a little bit of processing for astronomical photos. And Tim and you asked some questions that I wanted to illustrate some of the stuff that's better illustrated than talked about. If you take a picture of this sheep with a regular handheld, with a regular camera, whether it's on a tripod or not, doesn't matter. But you can see that this one is underexposed.
Right,
This one is properly exposed, and this one is overexposed.
right.
What that looks like in photographic software, where you're going to do something to the image, is it makes a histogram. The software makes a histogram. And these histograms are shown here at the bottom for that picture. And this distance here is the brightness in the image. And this distance here is the number of individual pixels that have that brightness. So you see in here, most of the pixels are dark. And so the histogram is shaped like this. The pixels are down here. They don't have much light, but there's a lot of them here. It's most of the pixels are dark. Here, this is a properly exposed picture for our eye. And here, most of the pixels in there are in the dynamic range where our eye can make sense out of it. Here, they're overexposed, saturated. A lot of information is lost in the histogram. So what you do is you just set it for the right f-stop and the right time, and you take a picture like this. And some cameras nowadays shows you the histogram, so you can judge, what you've got available, and you can adjust it. But
Jerry, a quick question. Once again, what does the X and Y axis in this represent?
The x-axis here is the
Wavelength.
The brightness.
brightness,
Brightness. Okay.
Right.
and this is the number of individual pixels that have that brightness. For each one here. So here, most of the brightness are in the mid-range, and it's clipped a little bit. So there are saturated elements in here.
Hey, Ron,
Yes.
did you realize this sheep does have a name?
The
Uh-oh.
Lambda.
sheep- Not a clone, is it?
He's talking about he was talking about wavelength and
Oh,
stuff.
I got you. Okay, Lambda, I got it.
According to Walt Disney, this is Lambert.
Oh.
No, that's Dilbert.
Gilbert,
Dilbert. This is Lambert. They have Ratbert and Catbert. This is
that's
Lambert.
right. Yeah. So
my,
anyway-
my camera will take 2 pictures, one overexposed, one underexposed, and then in the camera itself, it will combine them, the best of 2 of them, and give you a really good image. The other thing I'll do is, if I had a picture like the one on the left, use the magic marker in Photoshop, which would then draw, would separate the dark hills and back from the sky. So now I can process that two of them as separate images, and then put them all back together.
Okay, back on the rails here. This picture, when we take pictures of the night sky, it's obviously mostly dark. And so the images we want of nebula, they're way down here. So we have to run the exposure up to like an hour long, and we can do it in small segments and stack them. But we have to run up in an hour-long exposures to get something that's a usable picture out here. But when we take it down here, our initial frames are mostly dark frames. And when it's dark, you have to amplify them. When you do that, you have a lot of errors that are in the camera that you have to fix. Otherwise, you're going to amplify things that are not out there. And this is one of the things that you do. For our telescope, we put something that's white over the front of the telescope, and we expose light on that white thing. So we get a uniform field of white, and we take a picture of that. And what it shows is the vignetting. So out here, we have stars that are underexposed. We took a picture, and here we have stars that are going to be brighter, same star if you move it. So we can't just magnify the whole thing. We have to magnify things out here by a bigger factor than in here to get a balanced picture of what the sky shows.
Whoa, how do you do that?
This is what you take this picture, which is a regular picture of, you put something like a white t-shirt over the edge of your tube, and you shine a white flashlight on something, bounce it around, and then have it come in. And you
Okay.
take this exposure, and this tells you the vignetting in your scope. It also points out, there's none shown here, but if you have dust on the mirror on the window over your camera's filter chip, then you will see little donuts in here, dark donuts called dust donuts. There are some very faintly here. There's one here, and you have to amplify the light from those because they're going to attenuate the starlight. So you have to have a map of which elements to weight when you amplify it. Some you want to weight more. So that's one of the things you take, a calibration frame.
Right. Yeah, at Westmont, we do flats, Jerry, with just a big white panel.
Yeah.
And we point the 24-inch at the panel and just run the flats. Yeah.
That's the common way in big observatories, is to have
Yeah.
a white panel, and some you just look at it.
Mhm.
This is what's called a master dark frame, and it shows the thing that detects light is a little teeny diode made in silicon. And it's also, because it's a diode, it's light sensitive, but it's also an electronic component. And if you put a bias on it, which we always do, then it will run a current through it. It will run a current through. When you're looking at your image, you can't tell the difference between electrons that were produced by light and electrons that were produced by leakage in your detector. So this is a map. This is completely dark. There's no light coming into your camera at all. This is what's called a dark frame. And so you have to map out what the pixels add themselves to the frame. These are not stars. It will be confused with stars. And this is where it becomes important that your camera and your telescope combination not have pixels the same size as your resolution element, because some software later on will try and blend out any points like this as errors. And if the stars are the same size as points, it'll start taking stars out of your picture. So you always want to oversample your image by, at least in my view, 4x4 pixels for each of your faint stars. And so that way you can get, your software can tell a difference between a defect, which these are. So
How do you make a current around the detector junction?
Linkage current.
It's a diode, and when you run your camera, you put a bias across the diode. When you put a bias across the diode, a current runs through the diode. That's just the way diodes work.
And
Okay.
you can see it's a combine of 12 subframes because there's noise that's constant, but there's also random noise that shows up. And for this one, you want to get rid of the random noise.
Well, this appears random, but this is actually the dark current from your detector element.
Yes, but it's constant. It shows up in the same place.
Yes, it does. That's exactly right. That's where I'm going with this. You're
okay, but the random, the truly random stuff from cosmic rays and whatever will show up in other spots.
That's right. And there's other means that we deal with that.
Okay.
But this one, when you buy a camera and you look at this frame with it, that camera will have this pattern of these defects forever. It will never change. Well, your camera.
If as your camera ages, cosmic rays can cause some of these pixels to switch on.
Yes, they can do that. You can get radiation damage, but that's usually a spot here or there.
Yeah.
Now again, Jerry, I'm confused. A bias. What do you run a battery over your?
Yeah, no. That's just in your camera, and
the fact that your camera is turned on, Tim.
Okay. Okay.
So what you
the diodes are back biased. They have a back, and you're looking at the both the leakage current and the photodiode current caused by light.
Yeah, but this case you're not looking at the photodiode.
It's just the leakage current.
Yeah. This is just the leakage. Now this is tricky because these pictures, the amount of light you get here, because this is measuring the amplitude of the dark current. But the dark current is exponentially dependent on the temperature of the dark frame. So
Oh,
when you take a picture of the sky, you take it with your camera set at a certain temperature. When you take the dark frame, the temperature of your camera must be exactly the same as when you took the picture of the stars. And so this is why it's so tricky with DSLRs, because you can't control the temperature of the focal plane.
oh, I
So
see.
yeah, and so what I don't like doing this because this is estimating the size of it and it tries to take it away. If the temperature is slightly different, then the amount you're taking away doesn't exactly match the dark current. It's too much, too enthusiastic, or not enthusiastic enough. And so you're left with these speckle defects. What I like to do is, it looks like a dark frame, but it's not. This is a bad pixel map. It shows where the bad pixels are only, but it doesn't show you how bad they are. So what you do here is you apply software that the 4 nearest neighbors of each pixel highlighted here are averaged, and they replace the bad pixel. So
Wow.
the way it takes away the temperature dependence and the fact that you get the temperature error showing up in the dark frame. And
That's a lot of little dots.
It's a
Tim,
lot of them.
Tim, this is why you do binocular astronomy.
This is about 1% of the total number of pixels in here.
Oh gosh.
But this is, see, you don't have to do this yourself. You just tell it where the dark frame is, and it goes and subtracts it. It does all this for you in the software. This is what's happening behind the
that's a good thing.
Oh, I can't wait for the midterm on this one. I've got to
This is really good.
Okay.
Okay.
So when we make photo arrays in the infrared, and the materials are very tricky, and you see what your focal plane looks like in a dark frame, you think, oh God, where's the trash bin?
Yeah.
Throw the thing away. But when you do the right computer corrections, it just looks beautiful. Cleans it right up.
Huh.
So that's the end of the photo lesson for today. These are what's called calibration steps, and everybody does these, whether they do or not. Now, the late Bob Richard, when I would show this stuff, he would say, oh, you don't have to do all these things. I do it this way, he says. And what he's doing, he does exactly the same thing, but he has it all done automatically in the software. I do it manually because he says, oh, you never know what you're going to get. Sometimes it's a beautiful image, sometimes it's not. But when I do it manually, I know I'm going to get a beautiful image. But you don't have to do that. Bob's right. You can just go ahead, and software will take care of everything.
You mind going into this in deeper detail in future shows, Mr. Prez? Because I'm lagging.
I gave a talk on this about 10 years ago in one of our talks at the monthly meeting. Okay. And boy, I put the entire audience to sleep. So I looked out there and I think, boy, everybody is so sleep deprived.
This is really more a topic for the Tuesday night thing.
Yes.
Yeah.
And we do discuss this, the Tuesday night thing. But you had asked some questions about this, so I thought I'll just give you a little vignette.
I like it.
Okay.
All right. I was about to bring up infrared. I was wondering if the new technology.
Same deal.
Huh?
Same deal.
I'm sorry, what did you say?
Same deal.
Infrared is, because that gives us night vision, and it's the web, and I wonder if you have any of that brightens things. I don't know, because of the.
You do.
Okay. Let's talk again. Would you believe that was the 244th program? We're past our 4.5 year mark into our 5th year. And we're going to do this again next week, doggone it. Monday, number 245, and we'll be in November. We'll be in Daylight Saving Time. And Dr. Corngut of Caltech will be here on the first Friday. That's 2 Fridays away to talk about something also visualizing the universe from space we just launched. So until that time, gentlemen, thank you for convening with me. That's the SBAU Astro Hour. How do we say farewell in our club? somebody.
Hasta
Adios.
Nebula.
Bye, everybody. Good evening.